Hello everyone, hope you all are doing well. So let me introduce myself first. My name is Atharvan Anche and I am working as an associate security consultant at Redfox Security. So today we are going to talk about an interesting Android application vulnerability, that is StrandHogg vulnerability. Some people also called it as Task Hijacking vulnerability. Sounds interesting, right? So without wasting any time, let's get started with our vulnerability assessment. So this is Task Hijacking, or you can also call it as StrandHogg vulnerability. So this will be the part 1, and in this I'm going to tell you how we can identify if the application is vulnerable to StrandHogg vulnerability. So before that, let's understand what is StrandHogg. So StrandHogg is a bug in Android that lets fake apps look like real ones and trick people. Looks suspicious, right? So we will get a better understanding with an attack scenario I have mentioned here. So let's assume that there is a banking application which is vulnerable to StrandHogg vulnerability. So a user opens a banking app which is vulnerable to StrandHogg. A malicious app can intercept this action and display a fake logging screen identical to what would be found within the banking application. Unknowingly, user enter the credential and that are transmitted to an attacker. So giving you a understanding how this vulnerability works, we need to understand different components of Android. So let's first understand how an Android works and the different components of it. We won't go in deep, but we need to understand how actually an Android application is built. So let's go ahead. We are going to discuss about 5 Android components, that is activity, task, backstack, task affinity, and the launch mode of Android application. So let's start with the activity part. Now, what is an activity? An activity represents a single focused UI component that the user can interact with. Each screen in an app is typically an activity. So in simple words, if you have a login screen, you open an application, you see a login screen. So that is one of the activity. You authenticated it and you are redirected to a dashboard screen. So that is another activity. So these are some different activities in an application. So after you have logged in into a dashboard, you search for some other pages, you got a settings page. So that is a third activity. So basically a UI screen which you are able to see, it is an activity in an Android application. So another component is what is task. So when a user is performing all these activities in a combination, that is he has opened an application, he saw a login screen, then he passed the credential, he got authenticated, and then he served the application, he went to the settings page. So right now a user is performing a task. So tasks are defined as a set of activity users engage in perform an action or a workflow. For an example, every time a user completes activity like login, dashboard and settings page, they are performing an action and fulfilling a task. So that's all about the task part. The third component is what exactly is a backstack. So backstack serves as a last in first out thing. So often activities that have been launched in the task. So what I mean by last in first out. So for an example, user is performing a task where he navigates to activity 1, that is login page. He has opened an application, he is in login page. So right now you can see in the backstack history, the login page is saved. Now when the user has authenticated and redirected to activity 2, that is the dashboard, now you can see in the backstack there is a login as well as the dashboard page over there. So in the history there are 2 pages saved. Now when the user is surfing the application and he has redirected to another activity, that is settings page. So in the backstack there are right now 3 pages, or you can say 3 activities, that is login page, dashboard and settings. So this is the history of what a user is performing or what task he is performing. Now when the user presses back button on the settings page, he will be redirected to activity 2. Now when he was redirected to activity 2, the settings page from the backstack will be cleared. This is the process how it happens when you have terminated one of the activities, it gets cleared from the backstack. Now when the user clicks back button, or you can say logged out from the dashboard, then he will be redirected to login page, which will also terminate the dashboard from the backstack. So why this happens? So most of the times when you are redirected to login page after you have logged out, and that shouldn't happen, that you are easily just pressing a back button and you are again logged in. So clearing the backstack means that there is no other activities running in the background. So after a user clicks back button on the login page, the application gets terminated and it gets closed down. So this is how a backstack works in an Android application. So the another two main components of StrandHogg vulnerability is, the first one is the task affinity. So what is a task affinity? A task affinity in Android is used to determine which task an activity belongs to. Setting a custom activity task affinity, activities can be placed in separate tasks, and you can use this what you can say syntax to add the task affinity. So what do I mean by separate task? So let's assume in an application there is a login activity and there is a main activity, and once a user clicks on the application, he has shown the login activity where he can pass the credentials, and then he will be redirected to the main activity. Now most of the times developers uses task affinity to separate these two activities, that is the login activity and main activity. The reason behind is to terminate the session properly. Now let's assume the developer have set two different task affinity, that is for the login it is com.example.login task, and for main activity is com.example.main task. So now when the user is logged in and he have done all the task and he is trying to log out, when the user presses the back button on the login page, it makes sure that there is no activity in the backstack, and that will redirect him, or it will just close the application. So explaining this behavior properly, once the user logs in and transition to the main activity, the login activity is cleared from the backstack. When the user logs out of the main activity, it clears the main activity from the backstack and navigates to the login activity. If the user presses the back button on the login activity, the application closes entirely rather than going to the main activity. So this is how a task affinity works in an Android application. This is why this is one of the most important component for StrandHogg vulnerability, because when you are building a malicious application or an hacker application, you need to mention the vulnerable application's task affinity, or you can say the package name in the task affinity, so we can hijack the session. To get a better understanding, we'll go forward, so that will clear a lot of doubts. The last component for the Android application, and it is the main component which we are going to identify as well when we are trying to decompile the application. So what is this? What is launch mode? So there are four types of launch modes in Android, that is a standard, single top, single task and single instance. So there are four types of launch modes in Android, out of which we have been interested in only single task, which is vulnerable to StrandHogg. Now why is single task vulnerable to StrandHogg? The single task launch mode ensures that only one instance of activity is running in the task. If any other instance of activity with the same task affinity is launched, it will not create a new instance. Instead, it will bring the existing instance to the foreground, which could potentially hijack the task or display its own activity. Now just giving you a understanding this definition with an example, let's assume there are two applications right now. One which is vulnerable to you can say StrandHogg vulnerability, and another applications which is an exploit application which is prepared to exploit this vulnerability. So how an attacker actually build this application? He adds the package name of the vulnerable application in the task affinity of the malicious application, and make sure that the malicious application launch with the single task. Now single task, what it does, if there are two instances, you can say two instances nothing but two applications. If any one of the application is running in the single task, it makes sure if any other is running at the same time, it will take that application and it will join it to its session only, and there won't be created any new instance. So this is how an attacker can hijack the task. So we have understood a theoretical understanding of how a components of Android look. So you can check in this Android manifest file where all the components are mentioned. In the left hand side, so there are various activities. So there is a main activity, login activity, dashboard activity, and a settings activity. So these are all the activities in a Android application. When a user is performing all the activity in a collection, so nothing but he is performing a task, and when he is performing a task, there is always a backstack history which is going. So this is how the components look in the manifest file. Whereas the two more important components which were for the StrandHogg vulnerability, which was task affinity and single task launch mode. As you can see in the image in the right side, so there is a task Android task affinity com.example.login task and Android task affinity for main activity com.example.main task. So there are two different task affinity mentioned over here. So this is how all the components look into an Android manifest file. So why I'm showing you this, that most of the time when we are identifying the vulnerability, the StrandHogg vulnerability, we are going to check into the Android manifest file and we are going to check for different components itself. So without wasting any time, let's understand how we can identify now the StrandHogg vulnerability. So to identify this, I'm going to use a tool called JDX GUI. So this is the downloaded link. Don't worry, I will mention the link in the description as well. So what we are going to do in this JDX GUI? So we are going to drop our vulnerable application and we are going to locate to the Android manifest file, as I said, and we have to check if it is running with a single task, and second, if the Android SDK version is less than 30. If it is less than 30, then there is no patch available for task hijacking vulnerability. So without wasting any time, let's do the practical. So as you can see, there is a JDX GUI which is already installed or in my desk. So let's open it. Yeah, so we have opened the JDX. So let's drop our vulnerable application. Just drag and drop it here. That's it. So it will try to decompile the application and it will take less time. So yes, the application is decompiled and you can see a different components right now, like there is a source code, resource and everything. So we'll go into the resource part, and so there is an Android manifest file which we can check. So as I said, we have located the Android manifest file. So what we have to check over here, there are two things which we need to check. First is Android SDK version. So let's say minimum SDK. Okay, so yeah, there it is. So as you can see, the minimum SDK version is less than 30, so there is no patch available for it. And the second thing, which is the most important thing, the launch mode. Yeah, there you go. So the Android launch mode is into single task. Yeah, so this is now, as we have identified, now the application is vulnerable to can be vulnerable to StrandHogg vulnerability. So this is how we have identified StrandHogg vulnerability. So for the reference part, you can go with the blog written for the StrandHogg vulnerability in the Redfox. There is a good blog. There is a part 1 blog for StrandHogg vulnerability. So you can check it out and understand the logic behind it as well. So how was the session? I feel it was informative for you. Okay, we have identified the vulnerability. How we can exploit it? To exploit it, you need to wait for part 2. In the part 2, we are going to discuss how we are going to exploit StrandHogg vulnerability. So until we meet again, thank you.